All right, guys, welcome to part 4 of 7 and 8. Our first question here is talking about prime numbers, and you would have definitely talked about prime numbers before in math, but if you've forgotten, a prime number is a number that the only things that go into it are 1 and itself. So, for example, the number 5 is prime because the only things that go into 5 are 1 and 5. Nothing else divides evenly into it. The number 6 is not prime because 2 and 3 go into 6 as well. So this is a question that I think if you spend enough time on it, you'll get it right. It's just a matter of how much time you waste on it. This is not something you want to be dropping like 3 minutes on, trying all the numbers and stuff. So you need a quick strategy. The first thing I noticed right off the bat here is 81 is a number that most people know is not prime, because 9 times 9 is 81. So right there, I know that answer is wrong, because 81 is not going to be prime. If I do a quick scan right here, unfortunately, none of my other choices contain 81. But 63 is not prime, because 7 times 9 is going to be 63. So that takes out this option. And if you really weren't sure what to do on this one, just take your calculator and start dividing numbers. So like I could do, for example, 63 divided by 7, and oh wow, that's 9. So I would know in that case that 63 isn't prime. Another number that's not prime, which is actually going to do it for us, 91 is not prime because 91 divided by 7 is 13. They deliberately picked numbers that it wasn't very obvious what went into them. But 91 kills off these two choices for us, leaving us with choice J for that one. So the first one is J. Number 2, this first contractor charges a flat fee of $1,600. And then it's 2 per every brick, plus 2, plus 2, plus 2. You're just going to keep adding 2 over and over for each brick. And if you've had me as a teacher before, you know that I like to do this sort of thing. Before we write it, it's 1,600 plus 2x, because x is the number of bricks that we're actually going to use in this problem. On the other hand, contractor B charges a flat fee of $400, and they charge $8 per brick, plus 8, plus 8, plus 8, and so on. We want to know when these things will be equal. That's just a matter of setting 1,600 plus 2x equal to 400 plus 8x, which is going to be choice F. All right, moving on to number 3 here. We've got a situation where it's basically just working with numbers. It's a matter of figuring out what's going on, and they tell us blah, 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 stuff about berries. She has 10 cherries. We know for sure there are 10 cherries. I'm going to look through the problem for parts that involve cherries and see what I can do with that. It says she uses 3 times as many blackberries as cherries. Well, if there are 10 cherries, that means there have to be 30. Let's see, what was that? Was that blackberries? Yeah, 30 blackberries. So blackberries is one of the ones I actually had defined. I'm going to see what that does for me. Oh, wow. Just by knowing that, you've got it down to 2 choices. It's either got to be C or E. And let's see what else the problem has in store for us. Twice as many blueberries as raspberries. We don't know anything about either of those yet, so that's kind of useless to us. And the same number of blackberries and raspberries. Well, we already know there are 30 blackberries. That means that there should be 30 raspberries as well. So we have the same number of them. And if I'm looking through my choices here, raspberries are over on the end here. They both have 30 of those, unfortunately. So that didn't solve the problem for us just yet. Well, now we're just going to have to go ahead and figure out that last piece. It says that there are twice as many blueberries as raspberries. We have 30 raspberries, which means we have 60 blueberries, which means we are looking at choice E on that one. Okay, number 4 is a question I've used before, and it always surprises me how many kids miss this one. It's one that maybe you just don't understand what it's asking for. I always pictured this as a pretty doable problem, but you'd be surprised how many kids will miss this. They give us an equation, and they say that they want B in terms of E, A, C, and D. All that is saying is isolate B. Just get B by itself so everything else is on the other side. That's just a fancy way of saying that. The ACT uses this wording a lot. So we need to take this equation, E equals A, B, C, D, and isolate B. So A, C, and D need to get out of here. They're all being multiplied with B. A times B times C times D. So I'm going to divide to cancel out the multiplication by A, C, and D all at once. If I do that, I get E over A, C, D. Everything else cancels here, equals B. And that is going to leave us choice D on that one. All right, so number 6 and number 7 are both geometry questions. The first one is talking about the volume of a pyramid, but they did tell us the formula in this one. Like I've told you in the previous video, sometimes they'll expect you to know the formula, but sometimes they'll give it to you right in the problem. The volume of a pyramid is with base area B. We use capital B in probably your geometry class. So I'm going to just replace that with capital B because I like that better, but it's the same thing. So there's our formula right there. Now we have to figure out what's going on here. They tell us the height, and they tell us the volume, but they tell it to us in gallons. So I'll get to that in a second, but I'm going to go ahead and plug in my height. I know my height is 15. I know I have a 1/3 here. They tell us up on the top here that a gallon is 231 cubic inches. This answer, the 15, is in inches right here. So basically, this inches cubed is what I want my units to be on the volume. So I need to turn my gallons into cubic inches. Well, if 1 gallon is 231, 2 gallons is going to leave me with 462 for my volume here. And I don't know the area of the base, but that's what I'm looking for. I'll put my X there. We're multiplying 3 numbers, 1/3 times 15. I'm just going to multiply those two right now. And when I do that, I will get 5. So I'm left with 5x right here equals 5x is going to equal 462. And when I divide this one, I am going to end up with 462 divided by 5, 92.4. I kind of slowed down in this one because it's a little weird that they have just whole number answers there. Do they say that in the problem? In square inches? Yeah, I mean I got 92.4, so I'm going with choice A right here, although it did throw me off a little bit that they don't have decimals. But the actual answer when you divide this, 92.4, that's the area of the base, that's what they were looking for, that's going to be choice A. On number 6 right here, looks a lot more complicated than it ends up being if you're clever with how you do the problem. So we give a circle right here, and they tell us the area of this circle is 169 pi. If they tell that to us, we probably need to use it somehow. You need to remember the area formula for a circle that's usually not given to you. It's area equals pi r squared. Well, if my area is 169 pi, I can solve that and I can get my radius. So I divide both sides by pi, that's going to cancel that out. I get 169 equals r squared, and when I take the square root of both sides, I get 13 for my radius. Okay? So it still seems like, well, I mean, 13 is an answer choice right here, but you have to be careful with that sort of thing. That's just, I mean, the radius, this is not a radius right here. We want nm, that's this piece, that has nothing to do with the radius, it would seem. But I can draw in my radius in a clever way right there. If I draw this guy in, I can find the top half right here of this, it's called a chord in the circle, this line in the circle, by doing Pythagorean theorem. So I can do a quick a squared plus b squared equals c squared. And when I do that, if you do the math, I'm not going to show the steps here, you get x equals 12 for this half. So this guy is 12, which means this guy down here is also going to be 12, leaving us with, because we can just make another triangle, do the same thing, leaving us with a total of 24 on that one. So by drawing that radius in a clever way, you can make a right triangle and use that to help you find the entire length of nm. So our last problem right here is somewhat challenging, especially because they don't tell you what a single variable is equal to. They have r over s equals -1/2. And that doesn't seem like something you can do a whole lot with, especially initially. But the key to this problem here, I think, is to try to get a variable by itself. If I can get a variable by itself, maybe I can plug it in and see what happens. So what I'm going to do here on this problem is first I'm going to take, I'll rewrite my equation. R over s equals -1/2. And notice I put my negative sign. I don't like negatives out front in fractions. I put it up top here. I'm going to isolate r by multiplying both sides by s. So if I do that, I end up with r equals -1/2 s. Now, I can leave it like that, or I can get s by itself. I guess it doesn't terribly matter which one I do. I'm going to go ahead, though, and leave it like this. And what I'm going to do here is take my piece. I have 16r to the 4th minus s to the 4th. I have to say what that equals. I have r all by itself here, so I'm going to send this thing out. It's like plugging in. I'm going to plug this thing in for the r right here. So at least I have just s's in my problem. Then maybe I can make something happen with combining like terms and see where that takes me. So really what I'm left with here is 16. And then instead of having r to the fourth, I have negative 1/2 s to the fourth right here. So, and then the minus s to the fourth on the end. So we test this out right here. You can think about this. This means negative 1/2 s times negative 1/2 s times negative 1/2 s times negative 1/2 s, 4 times. Negative 1/2 to the fourth power is going to be a positive 1 over 16, because 1/2 times 1/2 times 1/2 times 1/2 is 1 over 16. So when I do this, I end up getting 16 times 1 over 16, and then s times s times s times s just makes s to the fourth. And I have minus s to the fourth here. 16 times 1 over 16, those just make a 1. Those go away. So I really have just s to the fourth minus s to the fourth. The answer to this is actually just 0, because something minus itself gives you nothing. So that leaves me with choice F on that one.